A very good morning to you guys. Today we are going to look at the Havard architecture. In the last lecture, we looked at the von Neumann architecture. Now we need to look at the Havard architecture and identify the differences between the Havard architecture and the von Neumann architecture. So in Havard architecture, machine code instructions are stored in different memory to data, are stored in different memory to data. Okay, so we are saying in the von Neumann architecture we realized kuti tinenge tine input here. From input we go straight to the memory, and to the output, and here is the CPU, okay, which comprises the control unit and the arithmetic logic unit. This is the von Neumann architecture. Okay, so we are saying this one memory chip, my instruction, what needs to be done. All right, so we are saying the instruction inofetchwa ne CPU inoita one cycle yekutarisa instruction yapinda memory, then yotora another cycle to process the instruction, okay, before it is displayed to the output. So one instruction needs approximately 2 cycles. One in the fetch the instruction, and the other one they execute the instruction. Okay, this was the von Neumann architecture. Now the Havard architecture, it's a bit different. It is when we have the input, okay, then we have a larger block, and there we have the output. Okay, so on Havard now, this is our CPU, the central processing unit, and this is first block, and this is the other block. So this one is the data memory. And this one is the instruction memory. Okay, so we are saying the data memory and the instruction memory are separate. Unlike the von Neumann architecture, is the same chip, but in Havard it's different. The memory is split into instruction memory and data memory, meaning to say you can search for an instruction and write some data at the same time. Okay? So this is the major difference between the Havard architecture and the von Neumann architecture. Now, let us look at the advantages. And we need to look at the advantages or the advantage of the Havard architecture. Advantage of Havard architecture. Now, the first one, or the major one, is the speed. Speed in what sense? The Havard architecture has got speed in the sense that you can one CPU cycle doing it an instruction can be processed in one CPU cycle, basically, with this approach, because we don't have to wait for the same data bus like ku von Neumann zokuti kune one data bus, instruction inofetchwa ne one cycle, then yozo execute kone the other cycle. In the approach Harvard, we are saying, since paine tuma data bus akasiyana, instruction no gonna fetch kwa ika execute kwa ne one CPU cycle, because memory ye data ne instruction are two different memory. Okay, so those need to have an architecture even faster than the von Neumann. And if you realize nowadays, modern computers, they are now using the Harvard as opposed to the von Neumann architecture, meaning speed. So what am I saying? Let me draw a diagram so that you understand what I'm talking about. So this is cycle 1, this is cycle 2, this is cycle 3, cycle 4, cycle 5. Okay, so we are saying with the von Neumann, we are saying we can fetch the instruction and execute the instruction. Then you fetch the instruction again, you execute. You fetch again, this is cycle 6, you execute. Alright, but with Harvard is different. You fetch in the first cycle, you execute, but while it's executing, you can still fetch, because instruction databus arakasiyana ne execute, so hapana chinokutadzisa kuita execute and fetch at the same time. Okay, then you can execute and fetch at the same time. You execute, while you're fetching, you execute, you fetch, you execute, fetch. Okay, so ukazonzwa zvichinzi Harvard inonzi pipelining, this is what we call pipelining. Okay, so if you look at, we have about 6 cycles. Now the von Neumann, which is the first one, per cycle 1 inofetcha, cycle 2 yoita execute, meaning to say 1 instruction yapera. Then per cycle 3 yoita fetch, cycle 4 you execute, cycle 5 you fetch, cycle 6 you execute. So per about 6 CPU cycles, von Neumann inenge yaita approximately 3 processes or 3 instructions ndo dzainenge process. But look at the Harvard approach. Right. Per 6 CPU cycles, inenge yaita instructions 1, 2, 3, 4, 5, about 5 instructions anenge process. So ukanzwa tichitaura issue speed, this is what we are talking about. Okay, basically that's what we are talking about. Now we move on to the disadvantages of Harvard architecture. Okay, now what are the disadvantages of Harvard architecture? Let me specify of Harvard architecture. Okay, the first disadvantage it comes with is the cost. Harvard architecture is a bit expensive, since in a more than 1 data bus. We are saying the volume and yanga iri a bit cheaper in the sense that irikushandisa 1 data bus with a board. But this approach now in a 2 data bus, are to separate instruction memory in a data memory. So this comes with a cost, because we are now adding another data bus. Okay, so this is one of the disadvantages or the drawbacks of the Harvard architecture. And the other thing is complexity. Complexity of implementation. This one is a bit complex. Near to data bus in it CPU or processor, really a bit complex. So that's the other disadvantage, yeah, the Harvard architecture. Now let's look at use. Where are these mainly used? Okay, these types of architecture are mainly used in embedded systems. Used extensively in embedded systems. Okay, can I check my embedded systems? What are we talking about? Tutorial systems are designed for a specific purpose, not for a general purpose. General purpose in the Harvard architecture, but for a specific purpose, we use the Harvard architecture. For example, a washing machine. Okay, in things like washing machines. A washing machine is an embedded system. Its duty is only to wash, so it has got a specific purpose. This is when we use the Havard architecture. Okay. Now, we are done with the Havard architecture. In the last tutorial, we did not look at the disadvantages or the advantages of von Neumann architecture, which I feel we should discuss in this lecture. Let's look at the advantages of von Neumann architecture. It's cheaper. Okay, that's the first advantage. It's cheaper compared with the Havard architecture. The other advantage is it's easy to implement. Easy to implement. Okay. Then let's look at the disadvantage. It is slower when compared with the Havard architecture. This one is slower, okay, because solutions are one data bus. So in the first cycle, you need to fetch the instruction, the opcode instruction. In the second cycle, you need the execute to execute the instruction. So in order two CPU cycles could eat one process or it process one instruction, whereas the Havard got one CPU cycle, since each one is both fetch and execute at the same time. Then basically I can say that's it, but there are more. You can as well go and research, but for the scope of this lecture, I will end here. Now we need to look at use of buses in computer architecture. Use of buses in computer architecture. Okay. Pananzima buses. Anushanda basari. When do we use buses? Things like that. Those are the stuff that we need to discuss. Now, I'll start by defining a bus itself. Now, a bus is a connection of wires through which data is transmitted. Through which data or data is transmitted. Okay, that is a bus. Now, the speed of a bus is measured in megahertz. That's the other point. The speed bus is measured in megahertz. That's the other thing. And the other thing is the size of a bus. Okay, we also need to discuss about the size of a bus. Now, the size of a bus, that is its width okay, is how many bits it can transfer at a time. How many bits it can transfer at a time. Okay, that's the size of a bus, as in its width. It's how many bits it can transfer at a time. For example, e.g., a 64-bit computer, has buses with 64-bit width. Okay, so papa pamunoti computer yako ichi is mine is 64-bit, 32-bit. That's what they will be talking about. Like how many bits. So we are saying a 64-bit computer is a processing power of 64 instructions can be sent at one CPU cycle, whereas a 32-bit can only send a maximum of 32-bit instructions or 32 instructions at one CPU cycle. So a 64-bit is more advanced than a 32. Back then, they used to be my 16-bit, my 8-bit computers. So due to technology, arukuramba upgrade, but now kwane ma 64-bit. Okay. Then the other thing about buses is buses can be unidirectional or bidirectional. Buses can be unidirectional or bidirectional. What are we talking about here? We are saying if a bus is said to be unidirectional, it means data can only move in one direction. Okay? So it makes an arrow in one direction only. That is unidirectional. Okay? Then a bidirectional. We are saying data can move to and from. So if bus data rinogona kubva from this point richienda this point or vice versa. Okay? But for a unidirectional, it's either left only or right only. it cannot go both ways. Okay, just take an example of traffic. Kana road ikanzi one way, it means motor can only go in one direction and not the other. But ikanzi it's a two-way, it means dzinogona kuti dzimwe dziri kubva dzimwe dzichidzokera, things like that. All right. Now we need to look at three types of buses. Three types of buses. Right. Now the first one, I will start with the address bus. Address bus. Now, what is an address bus? So this is a bus. This is the CPU or the processor, and this is the RAM, random access memory. Okay. So what happens is in address bus, okay, will send memory address along the bus. So basa raya kusenda a memory address to the RAM. Okay, so it sends memory address from CPU to memory. So memory router in this case is the RAM. Okay. So a continuation to fetch or write, or write data, to fetch or write data, and the other thing is that the CPU needs to tell the RAM the address. The CPU needs to tell the RAM the address. Okay. So what is happening is CPU inosenda address ku RAM. The address iri kusenda ndeyekuti data rira kufetchwa from what address, or unokwanisa kusenda address where data is to be written. Data riri kufanira kunonyorwa pai, riri kufanira kunoprocesswa papi. So CPU send address to the RAM through a data bus through what we call an address bus, because its main purpose is to takura ma addresses from the CPU to the RAM. And this one is unidirectional. Unidirectional in the sense that it's only the CPU inokwanisa kusenda ma address ku RAM, and not RAM sending addresses to the CPU. So this one is unidirectional. Okay. Now we move on to the second type of bus. Let me change the pen so that you see the difference. The second type of a bus is called the data bus or the data bus. Okay. The data bus is this one. Okay. Let's see kuti data bus rinoshanda basa rei. Now this sends the actual data to and from the memory. Sends the actual data to and from memory. Okay, so we are saying per address bus my addresses are kusendwa kuti go and fetch data from this address, go and write data to this address. But now the data bus, that data ratachitaura riri pama addresses apiwa the address bus is transmitted through the data bus. Now this is now the actual data riri pama addresses anga akapiwa rakutransmitwa. So rinotransmitwa neinonzo data bus. It's called the data bus because its main function is to carry the actual data, not the addresses. All right? I'm sure this is making sense. And this one is bi-directional. Meaning to say, data can be sent from the CPU to the RAM and from the RAM to the CPU. Okay? We move on to the last type of bus. Let me change the pen once again. Let me use green. It is called the control bus. The control bus. Now, control bus. Let me write the arrow for the control bus. Now, what's the function of the control bus? This one, it carries commands from the CPU, carries commands from the CPU and status messages okay, from other hardware devices. From other hardware devices. Okay? This is the function of the control bus. So we are saying, if we say it carries commands from the CPU and status messages from other hardware devices, we are saying do bus rinohandla ma-interrupts. Pane pekuti whilst computer iri kuoperate, power yapera, battery asina moto. This is an interrupt yekuti computer yakufana kudzima whether it likes it or not. So a signal inosendwa kuprocessor kuti battery power radhakwa. The computer has to shut down in so many seconds, 3 seconds or 5 seconds. And my interrupt anenge aine priority. So kana power yapera, interrupt yepower ine priority, computer inobva yadzima there and there. So that signal inosendwa kuprocessor kuti that's the status yebattery. So the machine will turn off or will do whatever it does. So that's the control bus. Ndio inocontrola ma status messages, pane error yabuda, things like that. Zvinoonekwa ne control bus. And it's also bidirectional. Okay? That is, it can go in both ways. So thank you very much for watching. I hope you have enjoyed this tutorial. If you have any questions, please don't hesitate to contact me at 0784 002 002. My name is Mr. Kuhuni. Good day.